Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
Now, is there any problem? For sure. Great. Let's move back again on R8, and whatever you performed here, like kind of redistribution, just remove it. No router, sorry, no router. First of all, router OSPF1, and then remove this command, and then say no router EICRP 100 from here. That's okay. Now redistribution is done only on R11. I have removed this redistribution now. Remove this primary and all these things as well. In place of 120, now I'll be having 130. Different, something different, right? Now I'm not going to include it, and here I will configure. Right. I'm not going to include this R13 right now. I will be discussing it later on with you. So now again I have performed redistribution on R11 only. So what I said here, out of SPF1 redistribute EICRP 100 subnets, and then I said metric type, right, is it was by default 2. I'm gonna to make it 1. Even you can also change your seed metric, and I have already taught you that how to change your seed metric. So now you can see that all of them will go as even. Even you can move on R7, and then also on R7 you can see show IP route pipe section OE1 this time. So all of them are coming as even, right? And even you can check it out in this manner as well via R11 itself. So because this time I have removed that redistribution from R8, so for all of them its best path will become via R11 only. Fine. Show IP OSPF database external 120.1.0. You see that seed metric is 20, and you can see route tag is by default 0. So if you want to add some routing tag in OSPF during redistribution, then go to your ASPR, and during redistribution you could also specify this command as well. That tag is what, like you want it to add 11, so that we can specify that okay, it was redistributed on R11 itself, right? So now if you move, even you can check it out on R11 itself. So IPOSPF database external, because first of all it will update its own database table, and then it will send those updates towards its other neighbors. So now tag is what, R11. Even if you move on R7 also, then you will find that its tag is what, R11, and sequence number have become now as 5. Previously it was 4, because I made some changes, right? Right. So in this way you can add your tag as well. And if you want to perform, if you want to configure some conditional redistribution, then you can also use route map here. Like on R11 I don't want to redistribute everything here in OSPF. I want to redistribute some specific prefixes only, like access list 1 permit 120.1.0.0.0.3.255. so only 1 2 3 first 3 prefixes will come into this range. Now is not it, then say route map redistribute from EICRP to OSPF, permit 10, match IP address is what, 1, and then go to router OSPF1, say redistribute EICRP 100 subnets, metric type is what, 1, tag is what, 11, and then you can say route map, and route map names, just copy and paste it. So whatever is permit inside the route map will only get redistributed from EICRP into OSPF, into OSPF. Fine. So this time you can see that here there will be only 3 type 5 LSs available. So IP OSPF database, let me show you. There will be only 3 type 5 LSs. See. Oh. Yeah. ACL was already there. Permit any. No access list 1. Say access list 1 permit 120.1.0.0.0.3.255. Now it will work fine. Show IP access list. Now see, show IP OSPF database. Check it out. Previously ACL was already configured on this device, and permit all was already configured. Hello.
Yes.
Let's continue it now. to IP OSPF database, you will see that all LSS will be available once again. Right? So now, is there any problem?
No.
Tell me. Fine. Now I'm having some problems here. Let's say that we have redistributed 500 prefixes from EICRP into OSPF. However, I'm having only 5, but let's add 2 more zeros into it. So let's say that 500 prefixes have been redistributed from EICRP into OSPF. How many type 5 LSS will be present in the database table of all routers?
500.
External LSA only.
Yeah.
Forget about some real LSAs, router LSAs, all those LSAs, right? But only external LSAs will be 500 LSAs. You understand? So, of course, it will be necessary for you to perform redistribution, because if you do not perform redistribution, then there will not be any communication. Fine. So you decided to perform redistribution, and you redistributed them into OSPF now. So all of them are having 500 external LSAs, and all routers were performing well, but you suspected on R7 and R8 that these two routers are not performing well. Their performance is now so slow. It have become so slow. Its performance have been degraded after performing redistribution. Now, because you suspected that okay, R7 and R8 are not performing well, and users are also complaining that okay, they are not having very good internet connection or internet bandwidth and all these things, right? Now you went there and you check out their hardware configuration, that okay, is it really possible for them to keep that much number of LSS inside database table as well as routing table? So now you came to know that okay, they do not have very good hardware configuration. They do not have very strong CPU, as well as they do not have enough memory available on these two routers, R7 and R8. Now you asked to your management that okay, we are required to replace these two routers, but they denied due to lack of funds. So you have to solve this problem now, and you cannot perform you cannot replace them. So for that purpose, here we are having area types. Do you remember stubby area, totally stubby area? So here we can configure stubby area. So now we decided to make it as stubby area. So as I said, that stubby areas are not allowed. Virtual links are not allowed in stubby area, and if you have configured virtual link in any area, then after you try to configure that area as a stubby area, that command will not be accepted. You see, on R1 I have already configured one virtual link over area 1, right? So now you decided to configure this area 1 as a stubby area. So what is it saying? So if you have already configured virtual link, then after if you configure that area as stubby area, it will not accept your command. And if you have configured any area as stubby area already, and then after you try to configure virtual link, it will not accept that command, because virtual links are not allowed in stubby area. And what are the properties of stubby area? Type 5 LSS will be blocked, will be filtered out. So now type 5 LSS will not be available in the database table of area 2. And R7 and R8, both of them are participating in area 2 only. So now if I configure this area 2 as a stubby area, you will see that those type of LSS will not be available in the database table of R7 and R8. And if those LSS are not available in the database table of R7 and R8, it means that those routes will also not be available inside the routing table of R7 as well as R8. Then how will it be possible for them to communicate with external users? For that purpose, ABR will be responsible to inject a default route into your stubby area after filtering type 5 LSS. So there will not be any problem related to their connectivity. So that now your devices will start to perform well, and also there will not be any connectivity loss. Still your users behind an R7 and R8 will be capable to communicate with external users. So let's configure this area 2 as stub area now. Now, as I have already instructed you that if you are going to configure any area as stub area, like here, you are going to configure this area 2 as a stub area, because you are planning to configure this area 2 as a stub area. It means on all routers which are participating in this area 2 now must be configured as stub area. I mean, you must configure this command on all those devices which are participating in that area. Should I turn on this fan? This
But R5 and R6 are virtual.
फैन ऑन कराऊं क्या? नहीं, बता दो. अब इस बार पानी डलवाऊंगा तुम्हारे मुंह के ऊपर में, तुम्हारे साथ साइड में जो बैठे रहेंगे. हाँ,
You said that in area 2, all the routers which are participating will start them and stuff.
exactly. Now let's move on.
And
R5, R6, R7 and R8. On all these four routers,
we have virtual link, right? R5 and R.
but not in area 2.
Okay. Yeah.
See, router of OSPF 1, say area 2 is what? Stub. That's what you need to configure here, right? Then you can move on. R6. Router of OSPF 1, area 2 is what? Then you can move on. You will see that R7 will break neighbors if I do not configure this command here on R7, because the stub flag will get mismatched.
Yeah.
Because this stub information is also contained by
Neighborship.
hello packet, and this stub flag information must match
Yeah.
to form OSPF neighborship. So IP OSPF neighbor, you will see that this is gonna to break neighborship with R5 now very soon. After 5 seconds it will break neighborship and it will not come up. If you say debug IP OSPF events, it will show you that neighborship is not coming up because of mismatched transit stub flag. Do one thing, route to OSPF 1, then say area 2 is what? Stub. Once you will configure it, then you will see that neighborship will come up with R5. See, but with R8 it will not come up. So IP OSPF neighbor, because still you have not configured this area as stub area on R8. So router of OSPF 1, area 2 is what? Stub area. After configuring this area 2 as stub area, now check the database table of R7 as well as R8. However, in the database table of R5 and R6 you will still find them. You know why? Because R5 and R6, they are also participating in area 0 as well as area 1. That is why it is not possible for R5 and R6 to filter out these type of LSS from their database table. You understand what I mean to say? So it means that external routes will still be available in the routing table of R5 as well as R6. That is why I always mention this thing, that ABR must have very good hardware configuration. And this time R5 and R6, both of them are working as an ABR. That is why it is mandatory for them to have very good hardware configuration. Right? So now you do one thing, move on R7 back, and on R7 check its database table. You will see that you will be having only router LSS and summary LSS. And if type 5 LSS are not there, then what will you do with type 4 LSA? That is why if type 5 LSS are filtered out, it means that type 4 will automatically filter out. What? Of course, there will not be any requirement of having type 4 LSS if you do not have type 5 LSA, right? That is why if you are filtering type 5, it means type 4 will automatically get filtered out. So that's the default feature of OSPF. Fine. So now from stub area you can see that they have filtered out all type 5 as well as type 4 LSS from the database table of area 2. But in place of them, you will be having a default route coming from both ABRs. See, R5 and R6, both of them are working as an ABR. That is why both of them have injected a default route into area 2, into stub area. Because now ABRs knows very well that type 5 LSS will not be allowed in stub area. So it means that it is mandatory to inject a default route into stub area. So they will automatically inject a default route in the database of stub area. So this area 2 is working here as stub area. That is why ABR, R5 and R6 have injected this default route in the database table of area 2. So is there any problem now? Tell me. So still you can see that you can trace route with 120.1.1. However, you do not have those prefixes here available, right? and then you can also trace route with 2.1. However, your trace route will never get completed. You know why? Because R12 do not have reverse path, ESERP. You have not redistributed OSPF back into ESERP. That is why your trace route will never get completed. So to do it, you do one thing, move on R11 and also say redistribute OSPF back into ESERP. So redistribute OSPF 1 matrix 1 5 4 4 0 to 5 1 and 15 100. Move back again on R12, show IP route. All of them will come as external prefixes here. Like you can see, show IP route 7.7.7. See, it's not it. And then you can also see show IP SCRP topology 7.7.7 and its subnet mask. External data and external metric is what? 320, which was available on R11 to reach this prefix. Hello.
Yes.
On R11 it was there. Show IP route 7.7.7. What is the matrix? That's why under external data we are having this external metric. This is inside the ESERP, right? Fine. Forget about it. Let's move back again on R7, and from R7 now you can trace routing. It will be done successfully now. Even from R8 also, like R8 do not have that route available inside its route table. You see, it does not have that. But still, if you trace route 120.1.1.1, it will go there. Because with the help of default route, it will reach R5 or R6, and then R5 and R6 are already having those prefixes available inside their routing table. So this time default route would be used by R7 and R8 just to get ABRs. And ABRs are already having these prefixes available inside their routing table. And you see that ABRs have injected this default route in the database table of stubby area, which is area 2, not in any other area. Like if you check the database table of area 0 or area 1 or any other area, you will never get this default route information. Like you can move on R3, and on R3 you can check its routing table. There is no default route available, right? But if you move on R7, then of course you will get the default route over here. You see, gateway of last resort is there. Even you can also get the default route as well as inter area. See,
Yeah.
as inter area, because this time this default route was automatically injected by ABRs into stubby area, and the default route itself is coming as, in the form of summary LSA. That's why it is showing inside routing table as inter area, because it is coming in the form of summary LSA, and that summary LSA is injected by ABRs into this stubby area. Now let's assume now I have configured this area 2 as a stubby area. So I hope that you have learned that what are the rules of stubby area. Hello, tell me, have you learned the rules of stubby area now? Like type 4 and type 5 LSS will be filtered out, and ABRs will be responsible to inject a default route after filtering type 5 LSS from its database table. Fine. Then after it, see, on R8 and R7 you are not having type 5 LSS, but let's say that still the performance of R7 and R8 is not good, because still it is having too many inter area routes available inside its routing table, as well as too many summary LSS available inside its database table. So because it is still maintaining a huge database table as well as huge number of routes available inside its own routing table. See, what is happening to you today? What? Reflection. Is it? Now I was saying that still the performance of R7 and R8 is not well. It's not good, because still they are maintaining a huge database table as well as a huge number of prefixes available inside its routing table. So what to do? Now we can make it totally stubby.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.